Hi all, my name is Avikshit Bhushan and I'm the Regional Director Asia Pacific for Aerospike. For today's session, building a real-time ingestion platform using Kafka and Aerospike, it's my pleasure to introduce Matteo Pelati. Matteo works as an Executive Director, Head of Technology, Data Platform at DBS Bank, and he oversees the design and development of the entire DBS data platform, leading a team of over 130 engineers. Matteo has more than 15 years of experience in software engineering, and in recent years, he has been focusing on scalable big data platforms and machine learning, specifically using Hadoop and Spark. Matteo has previously held different roles in startup companies and MNCs alike, leading engineering teams at DataRobo, Microsoft, and Nokia. With that, Matteo, please take it away.
Hi everyone, and thanks Avik for the introduction. In this presentation, I want to show a little bit how basically our journey towards building a data platform, and how we kind of evolved from a batch data platform when we started like 3 years back into more like evolving to a real-time platform, and how we decided to use Aerospike specifically, and what are the main reasons that led us to choose Aerospike for the purpose. So I'll start by giving you a brief introduction of what was our platform up until let's say 1 year back, actually, and how we have evolved it and how we are evolving it. Okay, so the platform started about 3 years back, and we, as I said before, we started with the proper batch-oriented platform. Okay, so you can see here that we have different layers, and we classify them in tiers. So we have tier 0, tier 1, tier 2, and tier 3. Tier 0 is basically the what we call a landing zone. So whenever a source system needs to ingest data into the platform, they drop some data into an S3 bucket, and our ingestion framework picks it up. Going from tier 0 to tier 1, tier 1 is the first layer after the ingestion, and all the data that's in tier 1 is standardized and cleansed, and mostly all the stored data in tier 1, like any of the major Hadoop platform, data platform, is stored in files actually, and primarily we use Parquet and Carbon data files, stored in mostly S3. Then we go from tier 1 to tier 2, and this is where we create our global enterprise model. I will get back to this concept later, but I just want you to remember this step from going to tier 1 to tier 2, because we are going to address it also in the when we talk about the streaming. So in tier 2, basically we have all the data that has been globalized using our enterprise data model, and basically from tier 2 to tier 3 is where all customer applications they come and they massage the data, they aggregate the data, they produce reports to be written in tier 3 that can be consumed externally. Now the consumption is data can be consumed from tier 2 or tier 3, and we have two different way of consumption of the data. One is using what we call GRAPI, which stands for Global Real-Time API. Global Real-Time API. And Presto, which is basically our SQL engine, which is basically to allow users to basically access to create dashboards. That's mostly the interface for dashboards. So having give you, now I gave you this picture because I want to talk about the next problem that we have. So as I said before, our batch ingestion is we have a source system, and the source system, they produce files daily. These are stored into S3. We go through an ingestion process, and that's where we store the data, as I said before, and then we have API, our API, and Presto getting data. Now, this was okay until we were primarily using batch formats, okay? But with the evolution of the source system, we started having the need for streaming, okay? So we have source system that started pushing events, like for example, mainframe system now we're able to push events from mainframe system. So we need to start ingesting data in real time into the platform. So our platform, as any of the platform that has been designed, and traditionally talking about the financial services where most of the source system are batch based, we face some challenges in dealing with real time. So first of all is the storage format. As you know, most of the data that is ingested into a data platform is stored into files, Parquet files. We use Parquet and Carbon data, which is a more efficient format, very similar to Databricks Delta. But the problem is that these formats are not very suitable for streaming, and especially if you are storing data in S3, S3 doesn't allow you to append data, and so it becomes very challenging to ingest real-time streams into the platform. The second thing is that the second consideration is that Kafka, it does have historical storage, and it does have a lot of functionalities to mimic a database system. I mean, with KSQL, you can run queries on Kafka, but the problem that we had is that we do not need to give access to the user only the historical records, the history of the record, but we need to somewhat project this record into a database system. And I'll get to this point later with an example, so that becomes clearer. Of course, the other option is to replace entirely the storage layer, which is currently file-based and S3-based, with a database system. But that will become prohibitively expensive. I mean, currently we leverage this S3 storage, which is cheap. If we had to replace everything with the database system where we can basically append data in real time and keep everything there, of course the performance is better, but we'll have to pay the cost for it. Now, let's go back to the when we discuss about the keeping the history of the of Kafka is not enough, because this is the scenario that we see multiple times from our source systems. We have different source systems generating events. These can be CDC from databases, from relational databases, or can be from mainframe like Kix events, and they all push these messages to Kafka. Now, many times, especially like I'm taking the example of mainframe, we get partial updates. Let's say, for example, for a customer can update his phone number, and the customer can update his home address. But what we get is two different messages, which are partial. So in the first message, we get the phone number update. In the second, we got home address update. Now you can understand that if we keep the entire history of these messages into Kafka, it's going to be impossible or very hard for an application to reconstruct the original record by processing the entire history. So we have to find a better way to address this. Now the idea that we came up is, why not having a shadow database that is going to be capable of replicating what is the state of the source system at that particular point in time. So if I take the example before where we have the address update, the address update, and the phone number update, basically what would be doing in this case would be projecting this data into a database where we basically apply the changes to an existing record. So as a requirement, we ask all our source system to send the event type, which can be an update event, can be a insert event, or can be a delete event. And we basically project this event into a shadow database. Now, as I said before, this database, and then I will show you how this fit into the entire picture, will need to have access through API and through Presto. Now, the question that came was like, what's the best choice for this database? We have several requirements. The database must be really fast, obviously, and it must be able to perform a lot of concurrent operation in terms of insertion and reads. And we don't really care about acidity, actually, because we don't do transactions in this database. It's basically all the operation are a single insert or single delete operation. And the other requirement that we need to be able to access from Presto, from API, and of course from Spark, which is primarily our main compute engine. So we evaluated different choices, and we definitely decided to go with key value stores. We discarded all the SQL option because we didn't see the point of using SQL in this particular scenario. And okay, so the first thing was very fast key value lookup, and this we could only get this from plain key value stores. We wanted a solution that was open source, and this is because it's basically a company policy. We're trying to move away from legacy solution and moving towards open source. We wanted to have a solution that was really fast, but we didn't want to have the burden of having everything in memory. So the ideal solution for us was something that was hybrid between memory and flash storage. The other thing that we were looking for was a solution that was like a share nothing architecture, because it's much more maintainable and it's much easier to scale rather than having a solution where you have different roles for different nodes like master, slaves, etc., etc. There is also another interesting aspect that, yes, we wanted a key value store, but we wanted something more. We wanted the ability to have to store complex data structures, not just simple key value, and having, as the other point says, secondary indexes. So of course we want a really fast key value lookup, but we want to be able to look up for based on other criteria as well. And that's what secondary indexes give us. And of course, last but not least, we want to have some commercial support because of course we want to go open source, but given the industry we're in, if things do not go as expected, we want to have a partner to work with for any issue. So based on this table that you can see, our choices ended up, basically we reduced the choices to two products. One was Aerospike and the other one was Foundation DB. Foundation DB is lacking some features, and that's the reason why we choose to go with Aerospike, which is giving us basically what we're needing. So let's go back to the original picture where we show the batch data platform, and I want to show you how the streaming component gets plugged into that. So we have the upper part that is basically the batch mode, and the lower part which represents the streaming. As you can see here, we have data that is being ingested into Kafka. We have our own, this is basically our own ingestion engine, which we call Flux for batch and Flux stream for the streaming data. And from T0 to T1, all the data after standardization and cleansing is pushed into another Kafka topic. And we also store the historical data in Carbon and Parquet format. But where it gets interesting is from T1 to T2. So this is where we do the, what I called before the projection. So we take all the events and we project them into what we call a real-time snapshot, okay? And at the same time, we forward the data to a different Kafka topic. And keep in mind also that we are not storing everything, the entire history in our snapshot, but we have basically a parallel snapshotting, which takes end of the day data or end of the hour data and dumps it into a file format. And this allows us basically to save on cost, because we only keep in Aerospike the data, the real-time data, which is basically the current day data or the current hour data. Do not forget that we need to be able to access this data both from our API layer and from our Presto layer. I will get to this later, but just keep in mind these components, because that's where I'm going to be focusing in the next slides. So as I said, we have an enterprise model. From, as I said before, from T1 to T2, this is where we create this enterprise model. And this enterprise model is basically a global model for the entire bank. So think about this problem that we have. In the bank, we have tens of different source systems. And all these source systems, they have the concept of a customer, okay? Obviously, a customer representation in a source system is different from a customer representation in another source system. And we need to unify all these models into a single model that is stored at T2 layer. Now, we started this work already with the batch approach, but then it gets more complex when we talk about the streaming approach, because at this point we have to unify the streaming model and the batch model. So this is where the thing comes in. Whenever the card source system pumps data in, we have our projector that not only stores the data into the real-time snapshot into Aerospike, but it basically globalizing the model to create a unified model across the bank. And the same goes with all the other source systems. As I said, this is a component that we call the Globalizer. The Globalizer is basically a custom component which has a DSL, is primarily written in YAML format, that allows you today to do data mapping. This is basically a streaming version and a new version of what Informatica used to do for a lot of companies, like create mapping fields from one model to another to create a global model. So all the ingestion pipelines that we have, they go through all these steps, especially we're talking about streaming. They go through they go to standardization, then they go to globalization, and then go to a projection step where the globalized data is actually projected into the database and into Aerospike. The other thing we need to talk about is the storage format. I don't know how many of you knows about Avro. I guess it's quite popular. It has become very popular with Apache Kafka, but many of you will know that every message coming from Kafka is basically in Avro format, and that's how you can leverage the schema evolution. So we said, okay, let's take Avro as the de facto standard for us. So Avro is a standard for the streaming part, but we said, why not use Avro also for storing the data itself? And on top of that, we can also leverage Avro for serving the data. Avro it also supports implementation of RPC services, which are very fast because it's a binary format compared to REST API, so it's much more compact and faster. And the other good thing is it's very well supports schema evolution, which is very, very important for us. Now, this goes back to what I was showing before, talking about the different components. We have the globalizer, the projector, and every data that is stored in Aerospike is also periodically snapshotted. So we keep the real-time data in Aerospike, and at the end of the day or at the end of the hour, we persist this data into files, Carbon and Parquet file. Now, the format, as I mentioned before, to link myself to what I mentioned before, the format used to store data all the way to Aerospike is basically Avro. But when we dump the data into files, we transform this Avro payload into Parquet or Carbon format. And Avro also gives us the ability to ease this transformation, because both formats they have a fixed schema. Now this is an example of how we store Avro inside Aerospike. Okay, the inspiration of this was taken actually from the implementation that Apple did on top of FoundationDB, where they leveraged protobuf to store data inside FoundationDB. We like this idea, and we basically apply the same concept because it allows us to have a very compact format, and at the same time having all the functionalities. So basically, what we supposedly that we have a format, a message, a record similar to what you see here, which is a customer with different fields. We basically create an Aerospike record, which where the key is basically the customer ID, and the payload is actually the full binary dump in Avro encoding of the record itself. As I said before, we need to access to some secondary indexes. So this is the reason why when we persist the data, we extract some fields to be represented in secondary indexes. As you can see here, for example, we have an index that is a country. So we extract the country and put it as a secondary field. Of course, this has side effects. One side effect is the fact that re-indexing some data is not going to be so easy because you know, it requires you to decode the Avro format and extract the indexes. But this was good, really good for us because we don't need those level of schema changes. Our structure is quite fixed. Now, once everything, as I said before, we have everything stored in Avro into Aerospike, and we have the periodical snapshots. Okay. Now, what we need to offer is the ability to query both sources at the same time. For example, when I access the data through Presto or through our API, and I'm performing a query of, let's say, a list of transactions, I want to have the current day data plus the historical data, because I might want to get data from today and tomorrow. And I don't really care where this data is stored, but we know as a data platform that the current data, the today's data, is stored into Aerospike, and the previous data is stored into the periodical snapshot. So what we have built is basically a data access layer and also a Presto adapter that is not yet built but is in development now, that allows us to connect to files and Aerospike as well. And this allows us to run Presto queries. We basically treat those as data sources, and this allows us to run Presto queries on both engines, on files and our real-time database, without the user having to know where the data is stored. There is basically a federation between the two storage layers, and we are able to serve the data through Presto and run and use SQL for the user, or through our API, which can serve Avro object itself actually, and on top of that, user can use GraphQL to access the data as well. So this gives you a little bit an overview of everything. Now, we still have some challenges, and the first one being the fact that eventual consistency, because what we have here is streaming and eventual consistency, and our data platform is not really used, is not just used for analytical purposes, but is used also for operational purposes. So you can imagine that there are some delays in real-time data coming into the platform. We're trying to reduce these delays down to 250 millisecond max, but you can imagine that there are some applications that maybe they're triggering operation directly on the source system, and then they expect to find the data, to query the data directly from our data platform. And examples are mobile applications that interact directly with the source system, but then they come to the data platform to fetch the data. And obviously there is this eventual consistency that sometimes it can be an issue. The other issue that we have is that streaming is good, but sometimes we face challenges because this core system, the source system, was not fully designed for streaming. So there are many hacks that sometimes they need to implement because the source system is not capable of offering full support, the entire 100% support for streaming. So let's say most of the time we can do streaming, but in some situation we have to fall back to batch ingestion, especially, for example, talking about mainframe system. Sometimes this is the thing that we face. So yeah, this gives you an overview of the evolution of our data platform and how we started using, how we introduced real time, and how we started leveraging Aerospike for bringing in real time data and basically gluing everything together. So yeah, this concludes my speech, and thank you very much to everyone.
Hey, thank you, Matteo. That was an excellent talk. So anyway, folks who attended this session, request you to enter your questions into the box. Unfortunately, Matteo will not be able to respond today. He'll be responding tomorrow. So please do come back to this session and check his responses tomorrow. With that, I thank everyone.